Hi, today my topic is about hemispatial neglect, and I would like to start from some symptoms that the patient experienced, but we, as people that don't have hemispatial neglect, wouldn't expect. So the first one is some of us might think that patients are not aware of their neglect, and that's why they have this condition. But that's not true, because based on the case study that Halligan and Marshall did, patient PP discussed her symptoms with people around her, with the experimenters and her husband. She has this fully awareness of what condition she has and what the condition looks like to others, but she still cannot do many of the tasks. And the other one is patients are ignoring left space by intent, neglect, because that's basically what neglect means. Neglect means they can't see the things on their left, but they are trying hard not to notice it. But that's also not true. Patient PP described it as, it doesn't seem right to me that the word neglect should be used to describe it. I think they thought I was definitely deliberately not looking to the left. I wasn't really. I think concentrating is a better word than neglect. She also described this as, it's painful to look left or concentrate on left, and there's nothing to neglect, which means left side is just not there for her. And after having the insight of her symptom, she still only draws the right side of a woman figure. So here's the figure she has drawn. As you can see that she still left out some of the left part of the figure, and she will, for example, make a drawing and then claim it's finished. And then she put her pen down, but after a few seconds, she will say something like, I bet I left out her left eye or ear or arm or leg. And then she can sometimes fill in some of the left part. But similarly, before she starts drawing, she would say something like, I hope I don't left out too much on the left side, but she will proceed to do exactly that. Here's the letter that patient PP wrote. You can see that she still can do like one line or two to write from the beginning of the paper. It's because she's trying hard to remind herself that there exists a left side of the paper, so that she can start from the very left of the paper. But as soon as she's not fully concentrating on the concept that she has this left side, she will go back to write everything on the right. And here's another interesting research that talks about how connectedness would affect hemispatial neglect. So researchers have used this chimeric pair, that the pair is either fully connected or connected with a line, or just separated with a central gap. And what they found is, so the task for the patient is to identify the left side of the chimeric pair. And what they found is, as long as this figure is connected to each other, whether it's fully connected or is connected with a straight line or a random curved line, the patient's identification performance is poor. But as long as you introduce a central gap to this figure, such as a central gap or just a broken line to this figure, the identification performance would be improved. So the researchers claim that it is because when this figure is connected somehow, either it's fully connected or is connected somehow with a line, our perception will perceive it as a single object. And the more the figure looks like a single object, the more severe the neglect is. So this research indicates that hemispatial neglect has this object-based reference frame. And I've also looked into some of the rehabilitation methods. So the first one is from Halligan and Marshall. They've used this method called Q in the left side. The task for the patient to do is they give the patient a straight line and ask them to bisect the line and right in the middle. And when nothing has been done before their bisection, patients would bisect the line at a three-fourths of the line because they are not aware of the left half of the line. They will just bisect the right half of the line. And this is the standard situation. And when they cue the patients that they have this left side of the line, their performance will be improved. But the effect is ascending. Watching the examiner mark the left end of the line before bisection has some beneficial effect on their performance, but this effect is less than the patient starting his bisection from the left side of the page, and this effect is less than the patient making an explicit mark at the left end of the line immediately prior to his bisection. And you can see if we introduce no delay to between Q in the left side and the actual bisection, the performance is very good. They can do the task pretty nice. But even it's just a 5-second delay between Q in the left and the actual bisection, their improvement was significantly dropped. So this is a really short-lived effect. And there's another research talked about a more long-lasting rehabilitation method, which is called the theta burst stimulation of the left hemisphere. The theta burst stimulation is just a newer form of transcranial magnetic stimulation, and their participants are all subacute ischemic stroke patients. They will do 10 sessions throughout 2 weeks. And after the 2 weeks of continuous theta burst stimulation, the BIT score improved by 16.3%, and at 1 month follow-up, the BIT scores improved by 22.6%. And the BIT score is just a standardized behavioral inattention test, which is what they use to test the severity of the hemispatial neglect. And they also have this placebo control group to compare with their actual real therapy group, and they just found effectiveness with the real continuous theta burst stimulation group. And the possible mechanism that they claim might be the reason is that this stimulation of the left hemisphere is counteracting the hyperexcitability of left hemisphere parietal frontal circuits, because they often found patients with hemispatial neglect will show this parietal frontal left hemisphere circuits have this hyperexcitability, and their results actually showed the hyperexcitability was reduced. And here's my references. Thank you.